Okay, about time to put some current through this beast, at least part of it. I apologize for the noise. This is not a good time of day to be doing this. It's about just a little after 4 p.m. You know, we're going to get traffic here, people coming home. I apologize. I'll try to speak over it. What are you going to do, right? So, a little bit about what I've got going on here. Of course, I got my DMM. I've also got a variac and a ballast. In this case, a light bulb. I think that's a 15-watt lamp bulb. This one here is a 100-watt. Get into that later. What I'm going to start with here is just to get rid of some crap and do some preliminary tests to see, you know, is this thing, is this main power transformer, is it soggy? Does it work? I'm pretty sure it does, just based on resistance measurements already taken. It's probably just fine, but we're going to find out. Not sure how much of a load test I'm going to do on this just yet. You know, kind of go along. So what I've got here, as I said, a variac variable transformer, and this ballast bulb. The input to this power supply, this variac, is in series with this 15-watt lamp. So all power going in to this, through this, into this amplifier must pass through this ballast resistor light bulb. So this is only going to let 15 watts pass, maximum 15 watts through anything I'm doing here right now. The advantage of that is, advantages are many. It saves you blowing fuses, might save your life, and it keeps you from making smoke. There are a few things in here that even for a moment, past 15 watts would just blow up. That does not mean you know, ignore caution. You can still be in trouble if you're not careful. And so, first of all, I'm going to turn this lamp off here, the stage light, so that you might be able to see better some of these, what's going on down here. Right now, into this variac, it has a regular grounded socket on it, and into that I'm plugging one of those three lamp ground circuit testers, just to verify that ground is connected to ground, hot and neutral are in the proper polarity. This lamp, this ballast, is inserted into the hot side of the input to this. So now to get this to light up, I'm going to turn up the dial, the voltage to this. Once that's shown, I'm going to plug in this most dangerous suicide cord. All three connections are there, hot, neutral, and ground, indicated by the wire colors. That will plug into this, and then these clip leads will go to the chassis. And we'll be able to tell if there are any troubles with this part of the power supply, with this ballast in place, if there's a dead short, this will light up brightly. Why not? I'll just go ahead and demonstrate what happens with that. But in the for now, and get rid of several hundred watts lamp. Looking at the camera here, yeah, I think you should be able to see that. I apologize for the noises outside. Hang on it. And those inside too. Okay, so turn this guy on. Now the voltage is set very, very low. In fact, it's set to 0. So there's practically no output to this. It's not going to light up till I turn that thing just about all the way up anyhow. These are neon lamps in here. But you might be able to see a very, very slight glow here. This 15-watt lamp. That's only what this transformer's dissipating right now. Very, very low wattage. I can turn it off. And this goes out, turn back on, comes closed very, very faintly. Not sure if this camera picks it up. I hope so. So right now, that's tiny, tiny little bit of current being drawn just by this transformer. I'm going to go ahead and turn this all the way up. And notice that this didn't increase brightness any. Why should it? The only load on it is now these 2 neon indicator lamps. This just to illustrate that it's connected correctly. With these, if the 2 end lamps come on, it's got a little key. It's got a little key here. With the 2 end lamps come on, it's where your ground is ground. Your hot and neutral are not reversed. Nothing's open. So that's the score with that. So I'm going to turn this off. Plug this suicide cord in with its clip leads. And I'm going to give this the full Monty, turn it all the way up, and turn it on. So again, right now, all we're seeing is power consumption that this Variac uses. Short out, I'm going to dead short, neutral and hot. All it does is light the ballast lamp. Also, I can short neutral to ground, no trouble there. I can also short ground to hot, also current flowing, good news. So any time current flows from hot to either neutral or ground, we'll know about it. And it kind of gives you an idea, of course, of how much. Is it a dead short, or is it looks about right? Well, if it looks about right, then we can change the ballast resistor to something a little bit stiffer, like a 100-watt bulb. And you can go as high a wattage as you want. Now, right now, this is none of this is plugged into ground fault circuit interrupter outlet. If it were, as soon as I touched ground to hot and current flowed, it would trip. I'm going to correct that by plugging this whole, everything you see here will be plugged into a ground fault circuit interrupter. So if current does flow into ground, which I'm going to attach to this chassis, we'll immediately know, because all the power is going to go off to everything here. I don't want that to happen, but if it does, it's better to know it that way than to get a nasty surprise. So there's the deal. I'm gonna turn this off, turn this down. I'm gonna apply power to the primary of this power transformer. There is something I need to pay attention to here. I'll explain that in moments. But yeah, I'm going to put some power in here, ballasted, and see what the secondaries are doing. And if that's looking good, it's not too far from actually plugging some tubes in. And check a couple of these capacitors toward the rear end, and I don't know, see what it does. As I mentioned in the previous vid, the electrolytics in this thing, I'll test them and maybe show that. In fact, likely show that. But in any event, I wouldn't run the thing for long with the existing electrolytics in it. It just makes no sense to me. If some of these molded guys, paper ones are good, I'll leave them. No. So I'm going to cut this and stitch it. I apologize for that noise. I live on a hill, and you know, you gotta step on the accelerator a little bit. And if this is so bad when I review it, I'll just do it over. See you in a sec. Okay. This is actually a second run. Too much noise first run, so do it over. And some points I missed, I meant to cover, and some points I made, it doesn't matter. So, alright. Got our ballasted power supply tapped in, and in a way, because there's no fuse in it and the power switch is turned off, neither line nor neutral are in contact with anything but the primary winding of the power transformer here. This death capacitor is out of circuit. This polarity switch is out of circuit, and this outlet, ungrounded outlet, is out of circuit. So none of that's going to be a trouble. I'm handling all this. Power's off right now. The earth green tap is going right to the same place that two center tap windings from this transformer will go, and that the shell and core laminations, all of it, are tied to chassis, and so with this also tied to earth. If any current flows through that right here, it will trip the ground fault circuit interrupter. In order to test that, of course, I can't plug into that. I've already tested it. It's good. For our purposes, right now, I just want to see, you know, are the voltages reasonable coming out of this? Keep in mind that I'm running this through a ballast, the Variac transformer, as well as this transformer. So the voltage is going to be lower than they would be normally. We'll get to that. So, and she goes. I don't know if you can see any glow. There's a slight, well, just the power this consumes. Turn it all the way up. Slight glow. A little bit brighter. Maybe you can see that. So this transformer's primary is drawing some current. Let's take a peek at a couple of things. The one we have to be real careful about, the high voltage output. Of course my meter needs to be turned on. AC volts 477, that's not bad with that ballast in place. That's not bad at all. More about that later. Turn the high voltage, turn the voltage high, just gotta be careful. And what's the voltage for the heater cathode of the rectifier with the ballast here? 3.4 volts. Yeah, 3.5 volts. It's about right. Normally, full power, this gets 5 volts, thereabouts. Okay. So, those windings look good. We'll look at this center tap of those just for fun. 237. 237. Perfect. That's both sides of the high voltage winding to ground chassis and center tap. And I ain't done. Not even gonna bother checking them. Yeah, why not? Can't hurt. Let's see, from ground to one side. Where's the easy place? Right there. Ground to one side of the heater string, 6.3 volts. Should be half that, but keep in mind with this ballast it's going to be lower. Yeah, I'd call it 2.2 volts. I think we can move that safely. The other side should be similarly 2.2 volts. Perfect. Okay, now there's another supply in here. It's the grid supply for the 6L6 5881's output tubes. And it's going to be a negative voltage, so if there's an electrolytic capacitor, it's out of view here under this solid state rectifier, silicon rectifier down in there. Because I'm not feeling any heat, and I wouldn't expect to, and this thing's drawing very little current, I don't think that capacitor is shorted. I do think that capacitor is probably got a very high equivalent series resistance. Let's clip on to the negative side here. Reference to ground. Oh, I'm on DC, AC, we're looking for DC here. Actually, AC, that's interesting. Across this capacitor, I'm going to go right across the capacitor. 86 millivolts of AC, that's a lot of ripple. That cap has to be on, that's 50 microfarad, 50 volt capacitor. That should not have, at 60 hertz, that ripple should not be there. That cap is probably just dried out. DC wise, 41 volts, minus 41 volts. Pretty good. And of course, there's a potentiometer here that allows you to adjust the bias voltage, from this raw 41 volts with the ballast. That's going to increase, or you might say because it's a minus, decrease some with no ballast in the circuit. I'm not at all unhappy with these results. We're not very far at all from firing this thing up with a rectifier in it. I'm going to have to isolate the high voltage electrolytics. At the very least, look at them. I cannot imagine that they're going to be any good. No. They got mold all over them, for crying out loud. So, I think we're in good shape here. Let's do another test. I can put this, yes I can. Disconnect this from what normally is the 125 volt line input, and I'm going to connect directly to the plate to plate, meaning I'm connecting across the primary of the output transformer. That's definitely not looking like a dead short. I'm only putting 15 watts through it. I know I'm not going to sustain that, but let's have a look. AC volts from the center tap of that to one end. 17, call it 17 and a half. And the other end, 17 and a half. I call that good. And that's on the primary of the output matching transformer. The voltage I'm measuring is from the center tap to either end. If I measure, it will be twice 17 point something or another across. Oh, if I can get in there. Yes, I can. Yeah, 34 and a half, call it 34 and a half volts. And it would be higher and much more current would be flowing but for this ballast. So that's good news. Do have to be careful. There is hot and neutral, hot through chassis. There are no tubes in this. There's some things you can do real quick. Shorted cap? No. Shorted cap? Not likely. Whoops. Where's that cap? This cap has resistors across it. I have to look in where that is in circuit. I see a meg ohm, 22 k ohm, 800 and what is that? 820 ohm. That could do it. What's that? This probably goes to chassis, and that does not. There's an electrolytic not going near that. So these caps here appear to be good. Those are 1 microfarad, 400 volt, almost positive that those are the ones that couple the grids of the output tubes to the phase inverter tube circuit. Turn them off. All right, so, oh geez, just for grins and giggles, let's go back across the primary of the output transformer with this. Turn it back on. Current being drawn as expected, and the voltage across these, just to double check. Yeah, Yeah, got 32 volts. What's on the output? If I plug the speaker in, well, I could plug the speaker in, couldn't I? Anyway, there'd be a 60 hertz hum coming out of it, which should appear here as, pardon me for bumping into the camera. No, that's very small. 110 millivolts. And let's make sure that's coming from where I think it's coming from. Yeah, it is. Will this reach? No, it won't. Or will it? Do I want to do that? Yeah, I kind of do. I'm going to tell you what. I'm going to unhookage that meter. Move that out of the way. Turn it off. Batteries, you know. And I'm going to carefully wheel this pivot. Almost reaches. Dang nabbit. Alright. Fit as good as a fiddle. Get it there. Oh, there we are. Alright, see, we want the speaker, not external speaker. Oh, joy. It's interesting. When you pull the speaker connection, it shorts the output to put some load on it. A dead short. Now, 2 ohms versus a dead short for that transformer is better than open circuit on its output. Might get into why that is. Just think of it this way: it creates voltage differences within the windings of the transformer that it's not designed to withstand. So right now it's the output of that transformer, meaning what would normally connect to the speakers, is shorted because there's no speaker connected, and so we're getting quite a bit of current. Well, quite a bit. Say some fraction of 15 watts, 125 volts flowing across the primary winding of the output transformer. Plug in the speaker and relieve it of a dead short and let it drive 2 ohms as it's supposed to. This goes right to, check it, dead short. Alright, now, are all of these all of the speakers are wobulating. I think we're in pretty good shape. I just moved the cabinet, out popped the connector. Do have to be careful. Does not sound to me as though any of those are rubbing. They're all working. All motors are working. I think there's hope for this old lady yet. I'm sure of it. Yeah, she ain't pretty, but neither was Janis Joplin, in my humble estimation. So, turn this off. And disconnect that. So, I want to go back to full fire, or I want to go to full fire with this output transformer. And before I do that, I'm going to cut out this grid bias filter capacitor. There's no reason to keep that one in there. It's open. In place that's a done. In fact, I'm going to cut it out right now. Cut it out of circuit. It's easier to keep track of which side goes where when you don't just remove it. That diode's obviously okay. We measured DC voltage there, not excessive current draw. Some ripple, that's because of this capacitor. It's not a full wave rectifier, it's half wave. So this really needs to be taking care of business entity. And these two, I am going to bring in the cap checker and double check, but these two, from what I'm seeing, can stay put for now, which is good. Often I do, and some others, they just shotgun every cap. I want to do that here. Why are these bent over? Okay, so got this out of circuit. Yeah, let's up the ante some. Turn it off. Well, limit to 100 watts. Safety ground and hot here and neutral there. Take a couple of voltage measurements. You should be very, very, very close and flip off. Very, very close. Yeah, 700. I call it 720 volts AC, peak to peak, from red to red. Not to be trifled with. Let's see, the 5U4GB rectifier, or GZ34, whatever the hell they had in here, it doesn't matter. Yeah, 5.24 unloaded, perfect. Well, let's look at the 6.3 volt heater string voltage. Good. Again, that's unloaded, so expect it to be a little high. And our 100-watt lamp here is now you need to think about getting light from it. Now, I would expect light from this if I short out one of the secondaries of this. Depending on circumstances, I don't recommend doing this, but I will do it. Let's see, I'm going to turn this off. I'm going to go across, right across the high voltage winding, and I'm going to go into the 10 amp fused. Now it knows. Oh, jeez, yeah, you gotta be there. This essentially puts a dead short across the set, that 720 volt tap winding. But I've got a 100 watt ballast. That should come on quite brightly with this variac turned all the way up, which I'm not going to start with. Turn it on. There it is. And how quickly that happens. So we're putting about 30 some odd volts into the primary of the power transformer. The secondary is pretty much dead shorted. By all intents and purposes, I remove that short. Wattage goes away. I go full Monty. No wattage. So, just to illustrate a little bit about why the ballast. Off, all the way down, and meter away. So, power transformer is fine. Output transformer is fine. I need to isolate those electrolytics, and I'm going to plug a rectifier in this and fire it up. At least the output section. I'm almost certain that that's going to fare well. You know what goes on up further up the stream? Nothing not fixable. There is a blown transformer in it. That's unfortunate, but not deadly. We'll see. Yes, we will.